So we're going to start with a model called economic order quantity. So-called EOQ model, and it was developed for the first time by Harris, 1913. Okay, this goes back all the way. What I'm going to explain is chapter 2, point something, 2.1, 2.2 of a book I'm going to be referring to called Factory Physics. You should read that chapter if you can. Okay. Basically, what we're trying to explain is we have a process, say a machine or a factory. We have a process. And we're trying to explain what is the best inventory to be held on stock so that we get best cost performance in the process. Basically, we have this process. This is time. And this is the inventory. And we have an order quantity. So we have a constant demand. And we see it in the line is going constantly down, like in a line, constant demand. We have instantaneous production. So if in T1, we say, okay, we're going to produce Q parts, they are being produced instantaneously. And this goes on and on. Ideally, okay, this is an ideal model. As you can imagine, it is not possible to produce 100 parts and deliver them instantaneously. Okay, so we start with an EC model. We know the demand, of course, is deterministic. And we are going to try to answer the question, what is the best level of inventory to be held, Q, to be produced or to be ordered, economic order quantity, so that we get optimal cost performance. Cost performance. So if the function of cost is epsilon or y, if we want best cost performance, what are we looking for? If this is y and this is q, What are we looking for in this curve? Best cost performance, mathematically speaking. What are we looking for in this curve for best performance? What do we want with our cost? To go down, right? So we want the minimum. We want to know which is the minimum cost. We don't want to pay a lot. We want to have a minimum cost, right? So a way to think about it is, let's say, a little example. Yeah. Here. Instantaneous production. So it just happens like that. In 0 time, you have Q parts produced and delivered. So you go down with your inventory constantly. You have a constant demand. And then you, in 1 second, you just go up and fill up again with Q. And the question is, what is the level you're looking for here? Imagine you are purchasing books in Amazon, okay? And you are, because you're a library shop, and you know, if you order 1 book at a time, just when demand comes, you come to the library shop and then you order the book. You have 0 inventory cost because you only are ordering what you have sold already. So you're not holding any cost. But in the case that somebody comes and you cannot deliver, you lose a customer. So there is a benefit in having some inventory in my bookshelf so that I can deliver whenever my customer is coming. And this is the case here, is there's going to be a trade-off between holding inventory, which is going to cost you money because you have to pay in advance and you don't know if you're going to sell it, and the purchase inventory, right? And the question is how you bring into balance the setup cost or this purchase cost and the holding inventory, as well as of the production cost. So you have here several variables. And we're going to analyze each one of them. So the first, I will do it with colors, so it's better to understand. The first is the cost of holding inventory. Okay, so it costs you money to buy a book and not sell it yet. You have to pay for a room to store the books. You have to pay for the transport to your bookstore. You have to pay for a bunch of things that, and you have not gotten any money back yet. So the holding cost is this H, which is a factor, multiplied by the average inventory, which in this case, which is the average inventory in this case? Q, yeah.
The high level plus the low level.
Yeah. That's right, yeah. Q,
Divided to,
yeah, Q plus 0 divided by 2. Yeah, so correct. So Q divided by 2. So very good. So this here, Q divided by 2 is the average inventory. It's average. Okay. So what we have here, remember that this y function is a cost. Okay. What we have here is the cost of holding inventory, and this is called holding cost. Okay. So, and this is a very easy function because it goes just up with Q linearly. Okay. So it's just like this, a line 1. I get another color, sorry. So any questions so far? If you hold inventory, if you have boxes in your warehouse waiting to be sold, you have to pay electricity, you have to pay the fork driver, you have to pay for the warehouse, you have to pay for water, you have to pay some taxes, you have to pay a lot of money just to hold the inventory. If you don't sell it, you're paying all the time. So if your order of quantity, if your quantity order, remember we're looking for the minimum. If your quantity of order goes up, if you say, hey, Amazon, send me 10,000 books of this 10,000 copies of this book. You just have 10,000 copies of the book. You have cost without end. Okay, just grows without end. Does it make sense? Yeah. And this is very easy because it's just the average inventory, which is Q divided by 2. Here, the middle, multiply by a constant H, which is what it costs to hold 1 unit. Okay? Any questions? Good. Then there's a second factor, which is the setup cost. A, setup, which is purchase cost. This is what it costs to purchase the material, the people, the information, and so on and so forth, so that you can have the what it costs to set up one purchase order into the system. Okay, so ideally we would just purchase one time, but it's very expensive. So we have AD divided by Q, because the whole yearly demand divided by Q is the times we place an order. So actually, T1 is D divided by Q. T2 is 2D divided by Q, and so on and so forth, until you have 1 year of the yearly demand. So this is the setup cost. You would love just to purchase once and never care again about this product. You purchase 100,000 books, copies of one book, and never have to care about it anymore. You just have it on inventory. Just sell it, sell it, sell it. You don't need to place an order every time, which costs money. Okay? So there is a trade-off. There is a trade-off, a balance to be found between the cost of holding inventory, a warehouse. Just imagine you have to keep a building, heated and illuminated and water and people keeping it and security and whatnot, holding inventory is costly, and purchasing inventory is costly because the truck needs to come, the DHL needs to come every time you order one piece of Zara clothes. Okay, so Zalando fights against this. Okay, because you order your clothes and then send the rest back or 80% of them back, so they have a problem with this. Not holding inventory. The inventory of the clothes is very limited. They have to fight against this setup cost. And then, well, this curve, 1 divided by Q, the rest is constant, is like this. This is the second curve. And it makes sense. The higher your order quantity, the less cost you have in setup. The truck only comes once. It doesn't come 100 times. If your order quantity is low, your truck needs to come every time you order one piece. So you have a lot of logistic costs associated. Does it make sense? And then there's a third term. I'm going to take another color. A third term, which is going to be the cost of production. It obviously cost me some money to produce. These parts. And we're going to understand C as constant. Okay, this is the third curve. So when we add up all these three curves, cost of holding inventory, setup cost, and cost of production, what we get is this. Okay. Be careful because this point doesn't have to be at the same level of this. Okay, so this point is what we're looking for. This is the minimum of Y. And we're going to call this point Q star. It's going to be the economic order quantity. Okay. This is the point which, if you order Q star, you get the best cost, which is the minimum cost. And I'm going to pause the video and I'm going to ask you to calculate this Q star point. We solve the equation here. The economic order quantity is the first derivative in Q equal Q star equalized to 0. This means that the first derivative of HQ divided by 2 is H divided by 2 is a constant, so we don't touch it. The first derivative of Q is 1. So it's Q to the 0 potent, so 1 plus AD multiplied by the derivative of 1 divided by Q. The derivative of 1 divided by Q is minus 1 divided by q squared plus 0, because these two terms are constant following q. So you have any questions? Well, then be quiet. If you have any issues, just go out and discuss. Thank you. And this in q equal q star. Basically, what we're doing is that a function of x to the point of n, the first derivative is n times x n minus 1. Okay, if n is 1, like here, then we have a 0 here, then we have 1 multiplied by x to the 0 pointer is 1. If we have a minus 1, like here, then we have n minus 1, and then we have minus, which is the reason for this minus, and then we have minus 1 is minus 2 is 1 divided by q squared. Okay, and this goes just straight to the result that, what's her name again? Anastasia did and solved. This goes to h divided by 2 equals AD divided by q star square, and this goes and gives us the solution that q square is equal 2 times AD divided by h. Sorry. Okay. This is basically the economic order quantity. This was the first result, the first relevant result today. And you should for the examination, for the exam, you need to do all the thing, you know. I don't need people that know this by heart. So if you learn this by heart and you don't understand how to get there, you get 0 points. 0. So I will not go and ask, given A, given D, and given H, tell me it is 50, it is 60, it is 70. No, because that doesn't make sense. I need people thinking each step. So now the second question is, okay, what is actually the cost that we're carrying? Given that we know Q star, we know it is the square root of 2AD divided by H. What is this cost? This is going to be the second result, so please try to do it. I will pause the video and I'll let you try. Looks like this. In this equation, in 1, you make Q equals Q star. So we take the first cost of holding inventory, H, at 2 below, and then where we have Q, we put Q star. Okay. Plus A, D remains the same. Where we have Q, we put Q star. Plus CD. And this equals H goes into the square. So we have 2AD, it's the same, and then H goes into the square, H squared. Okay, divided by H, which is this, and then we have a 2 plus AD, the same, and then we put AD into the square, 1 divided by 2AD, the same, divided by H, and then we have put this into the square, so we need to put it A squared, D squared. plus CD. And this equals, so the square eliminates this, and then we have the 2 goes in, so we have ADH divided by 2 plus ADH divided by 2 plus CD. This is just the same, so it's 2 times ADH divided by 2 plus CD, which if I put the 2 in this 2 inside, I get 2 squared ADH divided by 2 plus CD, which takes me to this shortens to 2ADH plus CD. Okay, and this is the second result. Okay. I'm going to pause the video again. If you have any questions. Now we're going to be talking about sensitivity. The third result that we are going to look at today is sensitivity. Meaning, what is the ratio, the error that we create if we do not order the economic order quantity? Hello? So, if we order something else than Q star, we have the holding cost, we have the setup cost, we have our minimum, Q star. But what if we order something different? Even what if we order more? Or what if we order less than what is optimum? What is the cost penalty that we are paying? Okay? What is the cost penalty that we are paying? This is what we're going to try to find out. And this is represented by this. Okay? So if we have, you notice that I'm going to simplify this term because it's a constant. Okay, so I will simplify it. If we have this from our knowledge now, this is the holding cost plus AD divided by Q. And here we have 2ADH. This is a simple transposition of terms. Then we go, and then we say here H2, H divided by 2 times Q prima times 2ADH plus AD times 1 divided by Q times 1 divided by 2ADH. Okay. This is just cutting this equation here. This equals 1 divided by 2 Q plus, okay, there are some steps in between. This is the result you get. This is an exercise for you as a homework. How you get from here to here. Homework. Homework 1, I would say. Homework 2 is if Q is 2 times Q star. Meaning, if I purchase or order double as much as I should, so I have 100% error in my order quantity. What is the percentage of error in my cost? We can do it easily. I can do it for you. This first example. Y of Q prima divided by Y Q star means 1 divided by 2 Q prima 2 times Q star divided by Q star plus Q star divided by Q prima, also 2 times Q star, and this means 1 divided by 2, 2 plus 0.5, 2.5, this means 1.25, so I have 25% error. So if I have 100% error in my order quantity, if I order double as much as I should, I have 25% more cost. Okay? Not homework anymore. Homework, you can, if you want. What if I order less? What is the error? What if I order half of what I should? What is the error? Think about it. Okay? Yep.
6.5.
What?
6.25.
It is going to be the same, actually. It's going to be 25% also. But
Sorry.
no problem. Just do it. You know, it's just a little example. Okay? Questions? This, as I said, is homework. So you want to do it at home. Why do I get this result? Questions?